Good morning, class. My name is Mario, and my partner is Wesley. Today we will be talking about data structures. We will begin with stacks. Stacks and queues are very similar, but a difference they have is in the way stacks operate. Let's imagine a stack of Oreos, where you can only get the one that is on top. This is how stacks operate. Next up is lists. We must not forget that lists aren't encapsulated by the rules of first in, first out, and last in, first out. Also, a list's members do not need to be next to each other in memory, meaning that larger lists are easier to store than large arrays or vectors. Like vectors, size is something we can easily keep updated with push and pop commands. Next are vectors. One of the main differences vectors have versus stacks and queues is an iterator. Another is that vectors will actually slow down the program. The iterator can be set to the beginning, somewhere in between, or at the end. One of the most flexible containers, with a weakness in that memory address needs to be next to each other. We can access any element by using brackets. Almost done here, ladies and gentlemen, don't fall asleep yet. The next topic we will cover is maps. They are very similar to vectors because we must use pop and push back or insert. Usually maps are used for applications that involve inputting data. A unique thing about maps are that we can insert values and stores them orderly by a given number. Long story short, they are containers that store values in a specific way. Now we will talk about sets. They are also containers that store values. Something to keep in mind is that sets do not contain duplicates. Data stored in this container cannot be modified, but it can be removed. Something else to take into account is the location. Values in sets are located differently. They require different accessible functions, like struct and type, to locate the element we are looking for. Now we talk about queues. What a queue lets you do is add items to one end of the queue, and remove them from the other end of the queue. Also, items are removed in the same order they were added. Unlike vectors, you must obey the laws of first in and first out. Last but not least is priority queue. This structure is very similar to the regular queue we just talked about, but with a fixed command. We use pop and push back functionos to work with the values found in these containers. These are useful in cases where one element is accessed more than another. Last, we must not forget that this is also a container that prioritizes the largest value by default as the first element in lists from high to low, which is where the name priority comes from.